Hi friends, welcome to my cooking show. Just kidding. Welcome to Manocha Academy, and this video is going to be about physical and chemical changes. I'm going to do some things here on my kitchen table, and you need to be a science detective and identify the physical and chemical changes that you see here. And then we'll finish off with our top 3 exam-oriented questions on this topic. Before we start, let's do a quick recap on physical and chemical changes. In a physical change, no new substance is formed and it's reversible. But in a chemical change, a new substance is formed and it's irreversible. So the 2 important questions to ask yourself when deciding the type of change are: is a new substance formed? Is it irreversible? If the answer to both of these questions is yes, then it's a chemical change. Otherwise, it's a physical change. So watch carefully the things I'm doing here and you try to classify them as a physical change or a chemical change. So are you ready? Let's start. I'll start by lighting this candle here. Now I'm going to make some lemonade. I'll show you my recipe. Hopefully it turns out good. So first, cut the lemon. I need powdered sugar. So I'm going to crush this raw sugar in the grinder here. Then mix the powdered sugar and water. Stir it so that the sugar dissolves nicely in the water. Now squeeze some lemon and add a pinch of salt. Let's drop in some ice cubes. I'll wait for the ice cubes to melt so that the lemonade becomes cool. Now let me enjoy the lemonade. It's perfect and refreshing. The candle is still burning. Can you see the wax that has melted here? Are you ready with your answers? In all the changes you saw, these are the chemical changes. In these changes, some new substances are formed. And here are the physical changes. In these changes, no new substances are formed. A burning candle is an interesting example where both physical and chemical changes are taking place. The physical change is the melting of the wax, and the chemical change is the burning of the candle. Now that we've looked at the examples of physical and chemical changes, let's look more closely at the differences between the two. For physical change, we'll use the simple example of melting of ice. And for chemical change, we'll use the example of burning of a candle. The first difference is that in physical change, no new substances are formed. So for example, when ice melts, you get water. It may look different, but chemically it's the same. It's H2O. If we try to represent the melting with a reaction, it would look like this. As you can see, it's water, H2O on both sides. Only the state is changing from solid to liquid. In chemical changes, new substances are formed. So in the burning of the candle, what are the new substances that are produced? The candle is a hydrocarbon, and on burning, it gives out carbon dioxide and water vapor. Of course, we can't see that because they are colorless gases. Here is the simple unbalanced equation for burning of a candle. As you can see in the equation, the hydrocarbon is combining with oxygen and producing carbon dioxide and water vapor. The second difference is that physical changes are reversible. They are temporary. For example, the melting of ice is temporary. We can easily reverse it by refreezing the water back. Chemical changes, on the other hand, are irreversible. They are permanent. For example, the burning of candle is a permanent change because once the candle is burnt, there's no way we can get it back. Let's add these two important differences between physical and chemical changes on our concept board. The third difference is regarding mass. In a physical change, the mass of the substance remains the same. But in a chemical change, the mass of the substance generally changes. Let's go ahead and verify this with the help of a simple experiment. In this experiment, let's measure the mass of the ice cubes before and after melting. First, let's measure the mass of the ice cubes. As you can see, it's 33 grams. Now I'm going to let the ice melt. After all the ice has melted to water, as you can see, the mass is still 33 grams. So in a physical change, the mass remains same. In a chemical change, the mass of the substance generally changes. Let's verify this with a simple experiment. For the experiment, I'm going to use this new candle and we are going to measure its mass before burning it and after burning the candle. I'm using this small candle because otherwise it's going to take a long time to burn. So first, let's measure the mass of the unburnt candle. The mass of the unburnt candle is 10 grams. Now I'm going to light the candle. Now let's measure its mass after burning. We are left with only 3 grams of the candle. So the mass of the candle has reduced by 7 grams. But doesn't this violate the law of conservation of mass? The law of conservation of mass states that matter can neither be created nor destroyed. So the mass should remain constant even for a chemical change. But in this case, we saw that the mass of the candle is decreasing. So how can you explain that? Well, the reason is we've been only looking at the mass of the candle. We haven't accounted for the gaseous products. Because when a candle burns, carbon dioxide and water vapor are produced. And they are gases. They go off into the atmosphere. And we've not accounted for their mass. So if this experiment is done in a different way, let's say we burn the candle in a closed container like this, then what do you think the reading is going to be? That's right. The mass of the container and the reactants will be the mass of the products and the container. So then the law of conservation of mass is going to be satisfied. The last difference is regarding energy. Now this is the confusing one because you find it expressed in different ways in different textbooks. In both physical and chemical changes, energy may be given out or it may be absorbed. But the amount of energy in physical changes is much smaller compared to chemical changes. For example, when you burn wood, you start the reaction with a small matchstick, so with a little amount of energy. But then we end up with a lot of energy in the form of heat and light. Now if you compare that to a physical change like melting of ice or boiling of water, energy is absorbed there, but it's much smaller compared to chemical changes. Let's pin the last two differences between physical and chemical changes on our concept board. So what do you think is the most important difference here? That's right. New substances are produced during a chemical change. But in a physical change, nothing new is formed. The irreversible point is not the most important one because a physical change can be irreversible. What are some examples? Cutting of a lemon or breaking of a glass. These are irreversible changes. But since nothing new is formed, they are classified as a physical change. For a chemical change, something new needs to be produced. Now that we are done with the concept of physical and chemical changes, are you ready for the top 3 questions on this topic coming up for you right now? Friends, I would like you to pause the video here and try solving these questions. Let's make this more interactive. So do post your answers and doubts in the comments below. And my commitment is to answer your doubts as soon as possible. I'm here to help, and I look forward to reading your comments. So I'm going to move away now and let you solve these questions. So I hope the concept of physical changes and chemical changes is really clear to you now. I would encourage you to put on your thinking glasses and look for these changes in your everyday lives. I'm sure you're going to find lots of them. And do remember to like, comment, and share this video, and go hit the subscribe button for my channel right now. Thanks for watching.